Started here today. So just first of all, welcome everybody to today's session. This is the 8th session in the Cyber Ireland Threat Intel series. Just to give a little bit of background on Cyber Ireland, for maybe those who are new to today's call. Cyber Ireland's aim is to build Ireland's cyber security community. We've just been 2 years old recently, and our cluster membership is growing by the month with over 120 organizations, 60 SMEs, and almost 40 MNCs. Just to give a quick overview of the Threat Intel Group. So we started roughly about a year ago, myself and Andy Greaves from SmartTech 24. We started this series and we have run 8 sessions so far. We grouped it into different phases, like initially starting off from 0. This is the 8th session, which is the end of the implementation phase. And then later in the year, we'll move into the maturing threat intelligence phase. So right now we've over 350 people in the threat intelligence mailing list, and we had 63 plus registrations for today's session. And I'm really delighted to have 2 great speakers here today. I'm probably a little bit biased because I work with these guys, but they're absolutely fantastic. So they're both from, they're really seasoned blue teamers from McAfee's technical leadership team. And Carlos and Ismael are going to really give a great unique insight today, I think, into something that will be very, very useful from a threat hunting perspective. And Carlos is a principal engineer, and he focuses on visibility and detection within McAfee. And Ismael is a senior principal engineer, and he's also a senior SANS instructor. So delighted to have the 2 guys here today, and you can take away, guys.
Thank you so much, Owen. I'm really happy to be here today with among friends. And being even virtually, maybe we can fix that and we can be physically right in Ireland sometime, like doing this, hopefully in the future, because it's like definitely one of my favorite places to be. So thank you for that. And yes, let's talk a little bit, and I'm gonna do like the boring part, right? The boring intro, Carlos. So we're gonna talk a little bit, just briefly, about what we do, because some people say AC3. What does it really mean? Well, AC3 means essentially adversary, countermeasures, and tactics. And if you ever heard me doing other presentations, I like to talk a lot about the think red, act blue philosophy. What is that? It's thinking like an adversary to be a better defender. And that's essentially what we're going to be discussing today. And Carlos is going to go deeper into Cybelistics. How can you apply that mindset, that philosophy, into something practical? So without getting into anything vendor related, or we're not going to discuss any of that today, what we do is essentially that, like thinking red, acting blue. We make tactics, techniques, procedures, right, TTPs, actionable. We study the attacker, we study their behavior, and we translate it into actionable countermeasures. And Carlos is going to discuss how we can break these down into even like further, right, into active and passive countermeasures. So we essentially do 3 things. One, we lead threat research and with the MITRE attack coverage in the product organization. So we are actually within engineering, within a product organization in McAfee, but we lead the efficacy efforts in terms of like MITRE attack coverage. And part of doing that is doing purple teaming exercises, right, to measure the efficacy, maybe similar to what you guys do in your organizations. And obviously we do that to improve the quality of our products. That also has a lot to do with working close with the engineering teams to build products that are more useful to practitioners. Both Carlos and I, obviously we have more people in the team, but all of us, we have a practitioner background. So we've been in the trenches, we've done incident response, we've been doing threat hunting, we've been leading SOC projects for some of the largest commercial and military organizations in the world. And we live and breathe blue teaming. So we know what works for a blue teamer and what it doesn't. So our work there is to make sure that we improve the security outcomes, once again, the quality and the efficacy of these products across the portfolio. And then the defense innovation piece, which all of these are obviously interconnected, but how do we continue to do more research on the new tactics that attackers are using to improve the visibility, the detection, and the efficacy of our products across all these different capabilities. Like sometimes when we talk about security products, we talk about prevention or detection and response. but I strongly believe that we need to talk also about efficacy in terms of investigations, right? Efficacy in terms of like threat hunting, because these are capabilities and skills are very much needed, but they also need to be supported by products in any organization. And we also translate all of this into a concept that I'm really passionate about, which I call defensive playbooks, which is how you defend against an adversary with specific steps, with specific instructions. This is what Carlos is going to show next. So Carlos, let us know a little bit more about how you understand all of this. And I know you love this term called cybelistics. I think maybe the people have an idea what that could mean, but let us know more, please.
Certainly, Ismael. And first of all, greetings to everybody over in Ireland. I'm in New York City and very big fan of cyber. Hopefully we can get there together, Ismael. As you said, cybelistics is the applied structured analysis of behaviors that are exhibited by digital artifacts in our world, the cyber domain. We take inspiration of other disciplines in the real world or the physical world that are known as ballistic science, right? If we pause for a moment, ballistic science inspired me to have this model because it's concerned with studying the impact of a potential artifact that can be used for harm, right? That's my example on the left. And what I want everyone to start thinking about here is look at the particular image on the left that represents the firearm. What's truly the mechanism that causes the impact? Is it the bullet or is it the firearm? If I take away your bullets, how effective is the firearm, right? Or what happens if I have a bullet, but I don't have a firearm? Can I still do damage? What is the effective range of a firearm of this type? When I say the effective range is how far can it be effective to be used by a motivated adversary, right? So can you actually acquire a target a mile down the road with this firearm? In the real world, that's not the case, right? And if we look at the cyber world, it's pretty much the same. You can have malicious code that is malicious, but it's a script. So what is the effective range of that script? Can someone become root with that script? Just by using a script. If you use VB script or JavaScript, can you effectively become root or admin in the Windows world? The answer is no, but the script can be used as a means to an end, right? In order to achieve that. You can have binaries, executables, like Mimikatz. This is a perfect example. The dimensions of cybelistics, it's represented there as 8 dimensions. It helps us in a structured analysis way, folks like us in AC3, to plot behaviors and what is the density or the potential impact. The farther away from the center, the more impactful the particular edge would be. So when we see the Win32 API there, we're talking about some serious APIs that could be used for process injection, not just any API. So this gives us a notion of understanding the uniqueness of Mimikatz. Mimikatz does not have network capabilities. It does not have capabilities to interact with tasks. It does not have capabilities to interact with the Windows services, which basically means that Mimikatz cannot establish persistence of the common world as we know it. That's what that graph is showing you. So an attacker has to combine now additional scripts in order to set persistence to steal credentials if they want to have Mimikatz activated at a point in time. So Cybelistics further allows us to assess impact so we can determine, well, what are the actions that we need to take to counteract the impact? Back to the item on the left with the firearm. In the real world, professionals of the physical security world take really great actions to counteract the impact of that firearm, such as wearing breastplates that are bulletproof. Although that is an approach to minimize the impact, that doesn't make it, 100% safe. However, it's the steps that they take. How do they know to apply that? Okay, so if we go back to the cyber world, How do we know when to use our firewalls to decrease the command and control? Do we block or do we monitor? How do we know when to take even those actions? When to block with confidence instead of when to monitor, right? So Cybelistics is really a structured way that makes that an easier process or sense making for you to actually have confidence of how you're going to activate the actions in your playbook, okay? So in a whirlwind, that is Cybelistics and what it means. Now, a key component I mentioned here is one thing is studying the behavior. Like a ballistics professional in the real world studies the projectile. How far does it travel, right? What is the angle that it is most effective in? And then they determine the countermeasures for that, right? So countermeasures is a huge, important piece of this approach to threat intelligence for defensive purposes. An active countermeasure, it is an action that directly engages the threat and neutralizes it, okay? You can think of this as a bow and an arrow, right? So if you put a shield, that is an active countermeasure. If you point it in the right way, it diffuses the arrow from achieving its objective. A passive countermeasure is a countermeasure that not really engages the threat directly, but perhaps starts to degrade the threat little by little. What is an example of a passive countermeasure? Wearing camouflage. If you wear camouflage, it's supposed to blend you in, but it doesn't really make you invisible to the enemy, right? Or a passive countermeasure here, it's another example, is what I'm showing here. If you monitor but do not block, you're observing the activity of a particular malware, but you're not blocking it. So you're not engaging the threat forward. So understanding active and passive countermeasures with what you have in your real world environment. If you have Microsoft Windows, you have products that are endpoint related from third parties. If you have many other things, you have to put them together and design the way that you're going to engage threats. So I'd like to show you now is an example of using the Cybelistics structured analysis to actually consume intelligence. And I'd like to ask you to please refer to the upper left-hand side of the presentation. There's a question. I'm not going to tell you the name of the program, but we're going to walk through this particular model bottom up. I want you to think, what is the maximum effective impact of range of the program based on the IOCs we will present? So start from the bottom up. This is the world of a lot of threat intelligence analysts. They are consuming these synthetic indicators, whether they're indicators of compromise or indicators of attack. You will very likely get from the registry run key areas. On the network side, you're told by some sort of threat intelligence sharing partner that you have ARC broadcasts or wake on LAN packets. You have the killing of tasks, task kill in Windows, that it sets up a task and it actually terminates the task in that way. You get more IOCs. And now you're seeing that for services. This particular service, McAfee DLP agent, is disabled, or the BMR boot service is disabled. On the file system, you get even more IOCs that tells you that the C users public is an area where something is written or something is copied, that these extensions are actually discovered or searched for. You also learn from IOCs that a particular program enables these two privileges. These two privileges, SE debug, is basically the equivalent of super root, if you will, in Windows. You can debug, look at the memory of every program if you have that privilege. SE backup privilege, that's a huge privilege to have in the Windows world. It basically means it can control large-scale volume information in a file system of the Windows OS, right? So these are IOCs that you're getting. Are you being able to understand these IOCs? We get flooded with these, right? Then you get other IOCs that talk about these two APIs, write process memory, create remote thread. Windows programs use these legitimately, but commonly an adversary, going back to your analogy, Ismael, is just think red, act blue. A regular programmer uses this for some important software design, right? You think red, the adversary uses these to inject into the memory of a process content, right? And they do create remote threat and now to spawn the process they injected. And if we act blue, what do we do with that IOC? Finally, we get even more IOCs that these particular load bins are used in different combinations. So ask yourself, what is the range of this program with every single dimension that we saw, right? It's got quite a lot. And if you look at the spider graph on the left, every single dimension is lit up in blue. The DNA profile of this program is that it touches every single dimension. This should really start being a mental concept that the intelligence professional says, what is on my radar? What is worthy of being on my radar? What if a program does not exhibit this depth of flexibility, of touching every capability in the model, right? Well, you have a program that essentially is less capable. Doesn't mean it's not useful for impact by the adversary, but this is a program that is exhibiting all of these properties, right? So as you ask yourself that question, now let's go into playbook mode using active and countermeasures with this very same indicator of compromise data set that we would get. Notice I go back to the bottom left, the diagram displaying that if you see the red shield with the X, that is an active countermeasure. And you see the blue shield with the check mark, that is a passive countermeasure. So now we're going to start from the top to the bottom. Look at the processes, VSS admin and the load bins. Well, I'm not comfortable with anybody deleting volume shadow copies in my environment unless it is the product that we bought. So with app control, I can actually set restrictions on who can actually activate VSS admin. So if I buy semantic backup, that's what I should be setting. I should not allow every program to actually spawn VSS admin. That is an active countermeasure. I take away that capability from anybody, removing volume shadows. App control is a perfect device for that countermeasure. On the Win32 API side, it's hard to block APIs, but if it's really, really hard to block, I don't want to lose visibility. So this is the perfect area where I can use EDR to keep track of those APIs, who's using them, what program is accessing them, and what's being passed into the memory space of a program. Here's the next layer. These are Windows privileges. With Windows Active Directory GPO, highly effective and with great processing and enterprise, I can restrict who is going to be the group in my entire enterprise that will have SE debug, including SE backup privilege. Typically, I have set up that the enterprise admin role in a Windows Active Directory infrastructure have these privileges, not even my help desk people. So now for every malware that wants to actually enable the SE debug in order to take over and do more damage and stuff, it is a deterrent that I just put in place with Windows GPO, okay? Next thing on the file system, DLP solutions can actually give us the ability to track specific file types. In my business, like your business, I'm pretty sure that you will agree, Ismael. If you have your business, probably 70% of the data that your business is producing and that it depends on, it's in Microsoft, Office format, right?
Yep,
so,
everything's on a PowerPoint.
We have other formats, but let's just go with the Microsoft Office data. If that is the data type that makes up the culture of your business, well, DLP solutions allow you to put in excellent conditions such as the PowerPoints, Word docs and Excels should be open or accessed by processes that it is intended for, such as the Microsoft Office programs. And you can actually disallow cmd.exe or PowerShell command line terminals from reading these files, okay? Now, I'm not saying that that is the solution here. I am saying is that type of creativity is what I have done with you as well in other places to minimize the impact of programs taking over the business data. And DLP effectively does that. We also have Windows ACLs that can protect core areas of the infrastructure where possibly highly sensitive or classified information relies, okay? So that's another example of applying active countermeasure and decreasing the impact. Here on the services side, my DLP agent is my security device. I absolutely do not want to miss who is allowed to remove that service, because that is the active countermeasure of the security investment we have made. So if we don't take a strong inventory of the Windows services that are critical to preserve the security posture of the infrastructure, we have failed. We have failed to protect ourselves, right? So again, here with App Control, you can actually pinpoint, depending on your product, which particular programs are authorized to interact with the service on the Windows computer. Specifically, which can terminate it, disable it, or modify it. If you don't do those types of techniques in your environment, then you're more susceptible to losing a lot of your integrity from the Windows services that are critical to your infrastructure. Tasks and jobs. Tasks and jobs are kind of hard. They're user tasks. So sometimes you can't really block. So you can still apply strong monitoring and awareness of visibility for tasks that are running. So you will at least have visibility in an attack when a task ran. Finally, we look at the network. The network, I think it depends. Ismael, you're more of an expert there than me. Blocking at the network, there are capabilities across multiple devices, firewalls, switches, routers. Most of the time, organizations don't tend to block, to not create outages or user experience issues. But a passive countermeasure to filter and focus on the right protocol, it should be important, right? Yep. So you don't lose anything by just having visibility, right? And last but not least, the Windows registry. Some Windows registry locations are very unique. This one right here, the run keys, that's very common. So perhaps you cannot block that, okay? Sure, then keep track of those run keys. So I ask you again to walk away from this slide. If the red shields mean where you can actually take action, if this was a threat, which it is, this is the Riot ransomware. Now I want to tell you that. How effective will the Riot ransomware be if you implement these countermeasures? That's what I want you to walk away with here.
And to me, the beautiful thing about this, Carlos, is that you essentially summarize the art of blue teaming in just one slide here, right? I think that if we step back a little bit and we realize what we're doing here, this is the art of defending. I'm going to define the art of blue teaming as translating the study of the adversary, their behaviors, into these applied countermeasures, actionable countermeasures that can be active or passive to counteract the impact, right, or reduce impact. And this is how to. This is a defensive playbook. This tells you what to do and how to do it. So that's what we should be striving for as blue teamers.
Certainly, Ismael. Thank you. So really take this forward as an Intel analyst. You should have two takeaways. The first takeaway is all the way on the right, I showed you a pretty common day in the intelligence shop. IOCs, terabytes of IOCs. Right? Okay, IOCs do not come with explainable or explicable context. So you're getting them, you're hunting for them. How can you actually know what they're intended for from the adversary at scale, and how to use that information to develop better defenses? Hunting is just finding the presence of them. As soon as you find the presence of those IOCs, you're going to have to take subsequent action. And that's what this is showing you. Oops, sorry, I'm trying to share. Okay. But now I want you to compliment me, Ismael, because I went into an endpoint mode with a process. I want you to show how this is also applied, but from the network side, Ish.
Yeah, just briefly, because I think we're running out of time here, but this is an example that I actually mentioned in a class that I'm co-author of, Security 530, Defensible Security Architecture and Engineering for SANS. And I think it goes really well with the mindset that you established, right, with Cybelistics. And one of the things I say here to my students is like, look, you have to examine the attacker's weapons. If you look at, for example, ransomware attacks, well, 90% of the ransomware attacks these days are taking place with tools like Cobalt Strike, Bloodhound, once the attacker's on the network, to discovery. So if you focus on understanding not only how they behave, but also how that behavior is influenced by the tools they're using, their weapons, it's going to be much easier for you to apply these effective countermeasures. So here's an example with something completely different. imagine the attackers on the network, and we know that that's the reality, right? That's what we talk about, zero trust and all these things. The attackers on the network, the attacker is trying to do something known as a machine in the middle, right? So the attacker is going to intercept the communication and, try to either interject or modify or sniff or do something like that. Something that we have seen in the past, and we believe it's something that we're going to be seeing more in the future, is the attackers doing an IPv6 over an IPv4 tunnel. Why? Because most organizations don't manage IPv6. They know or they think that it's something that is disabled on their network, but it is not. Either you're actively managing it or you're not. And if you're not managing it, an attacker could do this. So essentially in IPv6, without getting into a lot of details, there is something called neighbor discovery. And it's a type of ICMP packet that you send to the network, that routers send to the network to say, hey, I am your router, here's your prefix, right? And use this prefix to build your own IPv6 address. And now I can take you out to the internet over an IPv6 to IPv4 tunnel. So that's where you do the machine in the middle. And most of your security solutions might not be looking at IPv6, which means that you would be blind to this type of command and control. Well, let's look at how attackers can do this. And if you look at, for example, at the implementation of this attack in Metasploit, this is called a router advertisement, a rogue router advertisement. You will see a number of things. For example, looking at the description, you can see how this spoofed router advertisement comes with high priority. Well, if you look at how Cisco implements this in their switches and routers, these messages come with medium priority by default. So, okay, you're the endpoint, all right? You have IPv6 stack enabled, which is by default how most endpoints or all endpoints, Windows, Linux, and Mac OS are by default. And now you get this router advertisement from your legitimate switch or router. Is going to come with medium priority. Now you have one with high priority. Which one are you going to prefer? Obviously, the one with high priority. So things you can do. First of all, hunt, detect, observe, know what's normal in your environment. Second, active countermeasure. You can have all the routers, your managed routers, sending these router advertisements, these ICMP messages with high priority. That's active, right? Now you're mitigating the risk of something like this happening. Something else you can do, go to your routers, or actually in this case in your switches, and enable something that Cisco has known as RA Guard, which says, these are the ports on my switch that are connected to my legitimate routers. Those are the only ones that can send these router advertisements. And from a passive perspective, something you can do is to look at specific artifacts. For example, when attackers use this from Metasploit, and I always say attackers are lazy, because just because they can change the source code doesn't mean they're going to be doing it. Look at these indicators. I have highlighted a couple of those. Destination host, that's a multicast address in IPv6, looking at all nodes. Destination MAC address, it's fixed. Well, that's an IOC you could potentially be looking for. Again, an attacker can change it, but it doesn't mean they're always going to be doing this. I tell you, in many cases, attackers don't even look at the source code of these tools. They just pick them up and they use them, right? So that's another example. We look at two examples, how to translate these behaviors into defensive playbooks, actionable countermeasures on the endpoint, on the network, with two different scenarios. But at the end of the day, we also want to share this information, this intelligence, right, Carlos? So we want to share these for intelligence purposes, for hunting purposes. And that's where we want to show you a contribution that we're doing to the industry. We're collaborating with MITRE. There's a new project called MITRE Sightings, Threat Sightings, that essentially is meant to be consumed by the community by sharing what we see in the real world. And here's another colleague of ours in the AC3 team, Alejandro Hospanosian. And this is one of the threat sighting reports that he writes and he shares, where he's describing exactly what Carlos was describing before, the behavior of Ryuk. Right. And this has a very easy to read format, and you can see all of the different sightings in detail here, right? The observables at the file system level, processes, registries, command lines, anything that we have observed with this particular behavior, with context, right? The explainability. Why is, in this particular case, Ryuk doing this? What's the intention? That's going to help you as well to come up with your actionable countermeasures.
Yeah, I think one point to highlight what you just said, Ismael, is remember when I walked through my slide, I showed you get IOCs from everywhere, but you get a hash. Look at the description of what Alejandro did here. And by the way, MITRE has a format of sightings. This is completely custom from Alejandro. So this is the adaptation of the AC3 flavor of sightings. So notice you get a hash. What you're being provided here, you're being provided explainability. That hash was because Ryuk dropped it, but you're getting it in a machine readable format, right? Which allows you to further automate. You're not just processing hashes blindly, you know? So this format really helps to do two things. One, expressive ways that threat intel professionals can now express threats, comprehensive ways that consumers of that intelligence can have, even from a machine readable aspect. And last but not least, being able to actually implement them across machines in the YAML format, which can be easily imported elsewhere. So I think we brought everybody here today to let you know, you saw the entire intelligence structured analysis aspect, from receiving IOCs, contextualizing them, having a model to assess capability of the payload or threat that we're interested in, translating those particular model categories to active or passive countermeasures on the endpoint, or even in your example, how to do it at the network layer. When you're concluding with that, how do you actually put all of that knowledge together to share it with others? Threat sightings is a perfect example from our side. So I think with all of that, you know, we're done, and you know, we're so happy to have been able to share our thought leadership. We could sit now for Q&A. Great job, Ismael.
Thank you, guys. Back to Owen.
Hey guys, that was fantastic. I could listen to you all day. I think that was really, really great. And I know from some of the reaction, people really enjoyed that. We don't actually have any questions, and we're nearly out of time. But one thing I would just like to highlight, and you can touch on this one if you want, you know, if we look back at the whole series where we started about strategy, right, and we talked about threat intelligence platforms, I think one of the key things really for a lot of people here on the call to understand is when you're justifying what you need from a technical controls perspective, right, it's really, really important to understand the threat landscape and the threat model relative to your business, right, to really justify the tech stack you need to be able to implement some of this visibility for both active and passive defense, right?
Yeah.
Okay, guys, listen, that was absolutely fantastic. I think there is one question. So how do you balance operation requirements versus security considerations?
That's a very good question. And, you know, I think it's something you have to do there. And we touched a little bit on that, but it's obviously you have to do your threat modeling, right? Prioritize. Like we pick Ryuk, but, you know, each organization should be prioritizing what they're trying to fight, to counteract. And for example, I've been doing all the sessions, and maybe we can do that at some of the time on how to do threat modeling, practical threat modeling with MITRE ATT&CK, right? And the way you tie this to your business is by picking up things that are relevant to your organization. If you're in healthcare, for example, well, you know that ransomware is a big thing for you, or in education, or in government. Well, any company right now could be a victim of ransomware, right? So start with things that are really specific to your organization, and then look at what the impact could be. That's going to help you to drive some of these operational requirements. Obviously, you know, these decisions have to be made in alignment with the business, with the asset owners, and they need to understand what's the impact, right? What's the operational impact as well of having systems not being accessible, being down because a lack of security. So in other words, and this could be another conversation for like 1 hour, you cannot separate business continuity operations from security anymore. These things are really ingrained, and ransomware is you know, something that actually brought that together.
Okay, that's fantastic. I think there's another question. There's one more question. I know we're out of time, but I think everybody's enjoyed this session, so let's maybe extend it a little bit. What are the new challenges and threats that come from cloud-native architectures, and what do organizations need to do to combat these threats?
Ooh, I love those questions, and let me start first, Carlos, and I'll do the easy answer, and I'll leave you the hard one. No, usually when people say, "How do you defend the cloud?" The answer, you may not like it, but it's like essentially in the same way as you defend anything else. The only thing that changes in the cloud is who's responsible for what and the technologies you have available, right? In some cases, it's true you have limited visibility, but it is also true that the threats are kind of different. Right? For example, with infrastructure as a service, we're essentially like just moving systems to a different data center, right? Somebody else's data center. So you still have to look at the threat surface, and we still see a lot of campaigns against specific applications or server-side exploitation. But I think a big thing here as well is that you need to look at how do you secure things like infrastructure as code, because that's a whole different paradigm, right? What do you do with containers? You don't patch containers. You essentially like tear one down and bring some new container up, which means that you have to bring security into the earlier cycles of DevOps, and that's a whole different paradigm. So when you're looking at cloud native architectures, you still have to do the same thing. You still have to have the same mindset, but you cannot wait until all of this is in production to start looking at what are the active and the passive countermeasures I'm going to apply. No, you have to start looking at that like early in the development lifecycle and integrate as much as possible in your Terraforms or your Ansibles. And then obviously you still have to monitor this infrastructure when it is in production. It's another topic we could be talking for hours. I don't know, Carlos, if you have any other suggestions there.
No, you covered it, but what I will suggest to the person that asked the question is, the cloud brings one superpower for the blue teamer that now you must become comfortable with, and that is morphing. It allows the blue teamer to morph quickly. It's not like on-prem where you go disconnect the computer and all of that. No. So you have the superpower now of Kubernetes, right? You don't think like you do on-prem. You think like you do up there in the cloud. You have to be able to rapidly release. So the more you can embrace that new concept of technology, you no longer disconnect systems. You tear down and build right back up. That's the way you got to start getting comfortable with defending the cloud.
Okay, that was really great, guys. And I think, look, we're out of time here, so I'm just going to wrap up and just say that our next session is actually going to be September 29th. So we're going to take a break for the summer because I know there's a lot of people on holidays, etc. And we're actually sending out a survey right now. So I think it's in the link, but it'll also be sent to all the threat intelligence members and Cyber Ireland members. And, would really appreciate, everybody responding to that, because our next step really is expanding the core team. Right now, it's just myself and Andy Greaves to SmartTech 24. And it is hard to keep it going. So we do need probably a core team of 4 to 5 people. We do have 1 or 2 more people that have expressed interest. But if you are interested, please do step up, reach out to me on LinkedIn, or reach out to Owen Byrne or Anne or any of the Cyber Ireland community. And then what we'll do, as I said, we'll form the core team. And from that, we'll review the survey results and then decide for the next phase, which will be more the mature phase. We'll figure out, will we go more tactical level, like today, where we got really deep down into the weeds, or more operational level, whatever the case may be. But we will decide what the future sessions will be like based on your feedback. So we really want the community to decide how we kind of move forward here. So I appreciate your feedback. And apart from that, CI and EdgeScan will host a webinar on ethical hacking next week. So you can check out the event in the chat box. And finally, I would just like to say really a great thanks to Ismael and to Carlos. I think that was definitely my favorite session so far. It was fantastic. And I can tell by the fact all the attendees are still present 15 minutes into their lunchtime, I think they probably enjoyed that. So thank you to everybody today. The recording will be up there, and we'll see you all in a couple of months. And like that, everyone is more than welcome to get involved in this collaborative community. And if you do want to be part of the core team or just give your feedback, you can reach out to any of us. Okay, thank you.
Thank you, everyone.
Thank you.